All right, everyone. So we are going to solve some equations with variables on both sides, some with fractions, decimals, look at some special cases, and solve inequalities. This is our first video, so we're flipping the class. So I'm teaching you now through a video, and then when we meet, you should have all your notes from these problems and be ready to ask questions. So I want you to spend time listening to me now and not when we're in the Zoom call. And also, before I start, you see this math way? And it says, how can I help you? Just go ahead and say, you can't help me, math way. You can only make me think I know it when I don't. All right. Math way. In my experience, the students who use math way, they get it wrong on the test. So that's, you can do what you want, but I'm saying don't use it. Okay, so if I write it down, then you should also write it down on your paper. That's how it goes. And there is our equation. So the first thing we're going to do is combine like terms. How do we know if two terms are like terms? Well, either they're both just numbers or they both have the same variable with the same exponent. So I see on this right side here, 2p, a 5, and a 2p, those are our terms. So both these guys have a variable. And on the left side, there are no like terms, just a 17 and a 2p, and they're not like terms. Okay, so we're going to combine a 2p and a 2p makes 4p. So we just add 2 plus 2. No problem there. And now the second step is to use inverse operations. Inverse operations. So what is an operation? An operation in math is like addition, subtraction, multiplication, and division. Those are operations. So an inverse operation is the opposite operation. And it's because it undoes. So if you add and then you subtract, you're undoing, right? So we want to use inverse operations to isolate the variable. Okay, so we want to get the numbers. Let's get the numbers on the right side and the variables on the left side. So we see a positive 4p, so we can subtract 4p and then subtract 4p, and then that's gone, so that's good. Negative 2p minus 4p, both these are negative. When two numbers are both negative, you add them together. So 2 plus 4 is 6, and the answer is negative. So it's negative 6. And then we got 5. Right now, we got to get rid of the 17. So it's a positive 17, so we're going to subtract it. And that's gone there. Now, 5 minus 17. So 5 is positive and 17 is negative. Whenever you have one positive and one negative, you subtract those numbers. So 17 minus 5 is 12, and you take the bigger number's sign. So 17 is bigger and it's negative. So the answer is negative 12. 5 minus 17 is negative 12. All right, now we have negative 6 times p. So how do you isolate the variable? What's the inverse of multiplication? Division. So we're going to divide and divide. Ooh, right T. So negative 12 divided by negative 6 is positive 2. And we've done it. We've isolated the variable. How exciting. Okay, and I didn't need Mathway's help. All right, now when you have fractions, I'm going to show you a little trick. Although adding fractions is fun, but when we have an equation, we can actually do something to get rid of fractions. How many people would want to do that? So whatever the denominator is, you can multiply by, if you only have one fraction, multiply everything by the denominator. In general, multiply by the LCD. Hopefully you know that stands for least common denominator if you have more than one fraction. But here it's easy. We just have a 4, so we can multiply by the 4 because of the 4 in the denominator. And then what happens is 4 times 9/4, that cancels out the denominator, and it just becomes 9y. And then 4 times -12 is -48. 4 times 1/4, again, the denominator cancels out, and we have 1y. And then 4 times 4 is 16. And I'm not going to write the 1 because in algebra, we don't write 1s. We just know that they're there. Okay. So now we got to get the combine like terms, no like terms. All right, isolate variable using inverse operation time. So let's get the variable on the left. So I'm going to subtract y. 9y minus 1y is 8y. And now I'm going to add 48. And again, -16, positive 48. Subtract those numbers because one is positive and one is negative. And so that's a 2 and a 3. And I take the bigger numbers sign. So what's bigger, 16 or 48? 48, so it's going to be the positive 32. And now divide by 8. And we end up with y equals 4. Of course, I could be checking my answers, but so you check your answers by substituting. Or on Khan Academy by pressing the check button. Okay. So now to get rid of decimals, guess what? When you have an equation, you can also get rid of the decimals. So you just multiply by 10 or whatever the last decimal place is. If the last decimal place is the 100th, then you multiply by 100. Or, yeah, whatever last decimal is. So when we look at these numbers, the only decimal place is in the tenths. So we have to multiply by 10. And again, if it was in the hundredths, then we would multiply by 100. And what does that do? That moves the decimal place over 1 for everything. So now 10 times 12.6 becomes 126 because we just moved the decimal over 1. And then 10 times 4, well, you know that's 40. And then 10 times 9.6, 96. Decimal moves over. And 10 times 8 is 80. And then we do, I forgot the M. Now we get the variables on the left. I just like to always get my variables on the left, but you can get them on the right if you want. That's fine. So, right equals 96. And then we want to subtract 126. And we get -40m equals, all right, so one number is positive, one is negative, so I want to subtract those numbers. And 6 minus 6 is 0. 12 minus 9 is 3. So that's going to be 30. But I want to take the bigger number sign. So what's bigger, 96 or 126? 126, and that's negative, so it's going to be negative 30. And the last step is to divide by the number in front of m, the coefficient. So that's gone. And then that's the negatives cancel, and 30 over 40 is just 3 over 4. So it's 3/4. All right. Now, get serious here for a minute. We got to talk about an equation that may or may not have. How many solutions does this have? Well, this is in the number of solutions assignment, but actually it's a normal equation, because when we distribute the 3, we get 3x plus 15 equals negative 4x plus 8. So this one is actually normal. You could solve it and find it has one solution. But what about something like this? 2 times x minus 1 equal to 2x plus 3. Now, look at this. When I distribute this 2, I'm going to end up with 2x minus 2 and then 2x plus 3. Does anyone notice anything kind of funny about this? Hopefully you've said that both the x's have a 2 in front of them. So when I take my next step, getting the variable on the left side, what happens? Everything cancels. And that's not good. So what that means is either, number one, there's no solution, or there is infinite solutions. So the way you know is if you get something that's not true, that means, like here, no solution. Sometimes, though, you might have an equation where the variables cancel out. Like, how about this one? 3 times x minus 1 equals 3x minus 3. Now when I distribute the 3 and I get 3x minus 3, that's the same thing we have on the right side. So now my variables cancel, and I'm left with 3 equals negative 3 equals negative 3. The variables did cancel, but this is true. Negative 3 does equal negative 3. So that, in that case, we say there is infinite solutions. You can pick any number, and this equation will be true. And in this no solution, you could pick any number, and you would never get a true equation. One side will always be different than the other. All right, last one. Thank you, for staying around for this last question here. Negative 65y plus 19 equals negative 2y plus 41. All right, so inequalities, we're going to pretend like they're equations, and then when we get to the end, we are going to graph them on a number line. And the only thing that you have to remember is if you divide by a negative, flip the inequality sign or multiply. Divide or multiply by a negative. So let's see if that happens. I'm going to make sure it happens here. Okay, because we're going to get our variable on the left side. And negative 65 plus 2. 1 is negative, 1 is positive. Subtract those numbers. 65 minus 2 is 63. Take the bigger one sign. 65 is the bigger one. It's negative, so So we got negative 63, 41. All right, subtract 19, negative 63, 41 minus 19. That's no big deal. It's going to be a 2 and a 2. Is that right? 2 and 2. Okay. So now we want to divide by negative 63. Uh-oh, I'm dividing by a negative. So that means I'm going to flip the inequality like that. Okay. And then it says reduce any fractions. Don't round your answer. Don't use mixed fractions. Thank you, Khan Academy. When you get to Algebra 1 and beyond, we do not do mixed numbers anymore. It's all improper fractions. But this is a proper fraction. That's just in general. Okay. So now I'm also going to graph it on a number line. And 0 does not have to be in the middle of your number line. Although I am going to put 0 in the middle of my number line. So yeah, I am going to put 0 right here. It could be, sometimes I put the number that is the solution right there. And then I shade to the left or to the right of it. So keep that in mind if your number is like 100. You don't have to put 0 here and then tick over 100. Just put 100 right here and then start shading. So but since this is close to 0, we will put it right there. And we'll put negative 1 here and negative 2 here. 1 and 2. Okay, so this is between 0 and negative 1. It looks like it's maybe around a third or something. So maybe like right here. Okay, so that is where our negative 22 over 63 is. And now it's a greater than sign. So one year a student actually showed me if you just turn the inequality sign into an arrow, then you know which way to shade is pointing. So we're gonna shade this way. I always shade like. Okay, and then open circle or closed circle, who knows? It should be an open circle because it is not a or equal to. So when you do an inequality, you also want to remember to shade. All right, so just go ahead and post any questions you have about these questions as a comment on Google Classroom. And as always, feel free to like and subscribe.